This is a supplemental video to help explain homework problem number 43. A research institute reports that 69% of workers reported that they and or their spouse had saved some money for retirement. Complete parts A and B below. Part A asks, if a random sample of 50 workers is taken, what is the probability that fewer than 28 workers and or their spouses have saved some money for retirement? So this scenario is a binomial distribution scenario because it has two outcomes. They either save money for retirement or they don't. So we want to pull out our variables that we need. For instance, the sample size, or the N, is going to be the sample of 50 workers. The probability of success, in this case, it's the probability that people save money, is 0.69. That's based off of the 69% of workers, and we'll just convert that as a decimal value. And then we need to solve for a specific probability. In this case, it's the fewer than 28 workers. So we have to remember that in Excel, it always reads our probabilities from left to right. And so since we're working with a fewer than, that means it's a less than scenario. We're going to be using the formula as is, because it's going to be reading from left to right, from 0 up to 50 workers. So we're going to be using this formula right here, binom.dist. We're going to plug in an x. We're going to plug in our n, our p, and it's true because it's cumulative in that it's adding up multiple probabilities. So here we've got our curve between 0 and 50. And we need to break out what it means when it says fewer than 28 workers. So for this to work, we have to revise the scenario to state an x is less than or equal to some number. So if I say that there are fewer than 28 workers, that does not include the 28th person. Fewer than 28 could be 27 workers, 26, 25, and down. So if I actually draw it on my curve here, for instance, we just break it up. Imagine right here is the 28th person. Fewer than 28 means I start at 27 and go down. So that's why what I'm really trying to solve for is this part of the curve, where x is less than or equal to 27 workers. It's just another way of saying the same thing, that this is also saying less than 28 workers. And so that's why we have to modify the x in order to properly put it into our formula here. So I would plug in 27, my 50, and then my probability, which is the 0.69. And then plug all that into Excel, and I will get my answer that way. And then in part B, it says, if a random sample of 60 workers is taken, what is the probability that more than 48 workers and or their spouses have saved money for retirement? So we'll note that the N did change. It's now 60 workers. So I'll just make a note here. And our P is still the same. That's based off of the 69%. So that's still going to be 0.69. And then we also need to look at the scenario and interpret what it's asking for. So here we're looking for more than 48 workers. So it's helpful to rewrite this as a math statement. So more than 48, right? So we'll do x is greater or equal to. So we always have to have that equal to in there to really understand what it's asking for. More than 48 workers means I'm not including the 48th worker. I am actually counting starting at 49 and up. So that's why the x value here that I'm solving for is x is greater than or equal to 49. Again, it can be helpful to imagine you've got all 60 workers standing in front of you. And when it says more than 48 workers, I am standing in front of that 48th person. They're not the one I'm counting. I'm starting at 49 and up. Okay, now let's think about it in terms of Excel. So Excel, again, when we're working with our distributions, Excel always reads from left to right there. And in this case, we start at 0 and our sample's the 60 workers, so it goes up to 60 right there. Now, if I'm looking for 49 or more workers, I can maybe sketch and imagine it's somewhere right around there. So this right here is this part of the curve, right? So this is my, if I draw my line, 49th person starts right there. 48th person is on the other side of that cutoff. And since I want to know the right side of my curve, I'm going to have to work with my binomial dist formula slightly differently. Because again, in Excel, it only knows how to read left to right. So this right here is x is less than or equal to, you guessed it, 48. So that's the left side. But I don't care about the left side. I want the right side. So that's why whenever we're doing a greater than scenario, our formula is always going to start with a 1 minus, because the 1 represents the entire curve. 1 represents 100% of our data in that curve. And then I'm going to subtract the part I don't want. So I don't want this part of the curve. Need to remove, because that's going to give us the right side, 49 and up. So that's why I have to now subtract the binomial.dist of the values we don't want. In this case, I'm going to get rid of 48 or less workers. So the x value I will enter is the 48. My n is the 60, right, that went there. And my p is the 0.69. And then true. So be careful when plugging in this x value. This right here is what we are getting rid of or subtracting in order to get what we actually want, which is this right here. So I'm getting rid of my left side in order to find the right side of my curve. And we have to do this with our x values because in chapter 5, we are working with discrete random variables. That means it's things that we can count. In this problem, we are counting workers. I'm counting 49 and up workers that I'm interested in that save money for retirement. I'm not interested in the probability of 48 or less workers saving money. That's why I have to use this formula right here. Now, the good news is this counting up and counting down with the x value only applies in chapter 5. You don't have to worry about it in chapter 6 and on. So keep that in mind as we work through the content, and if you have any questions, just let me know.